Hello, good morning. Okay, so we are gonna do planning. So what's happening now is you know that planning questions will be tested and it will cost about 5 to 6 marks out of the practical. So that is equivalent to 2.5% or 3% of the entire O level grade. So don't get me wrong, I know planning is something new. Yes, it's something new. You may be uncertain about it, you may feel worried. We still study for it, but when when you go for your practical exam for mid-year and prelim and O level, remember where the bulk of the marks is. Your actual QA, titration, and your graph question. So you get that you master that well. This is something that can push your marks higher to pretty much try and guarantee that you get the A1 that you deserve, or the A1 that you want, you see. Okay, so let's take a look at planning. So generally planning, right, there is acronym per se here that we are looking at. AMCA, which means approach, method, calculation, assumptions. So approach means what the experiment is about and what to record in the experiment. Approach, sometimes you may want to think of it as what is your aim? What are you trying to do? Method means literally the steps. What are the steps to take for the experiment? Meaning literally you need to tell them how much to add, what chemical to add, what concentration to add, the exact details. So an example is, okay, remember QA? Sorry, do you remember salt preparation? Oh, salt preparation, you need to use something about excess solid, this one to to hot acid stir, it's something like that, but with greater detail to the extent where you need to tell me how much mass, how much concentration. Calculation, calculation, how to calculate? You don't have the data one. So let's say you're doing an experiment, then you're supposed to collect a certain the gas collected in, let's say, a particular time. Okay lor. Then you will say, oh, your steps, blah 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 blah. Okay, so let's then after that, let the volume of gas collected be x cm cube. So you use x cm cube to do your calculation to lead to whatever you are still trying to prove. So you use the unknown lah. So which is more concept. And assumptions wise, it can have, it can don't have. It depends on the question. Usually, if the question want you to write down an assumption, they will write it out for you lah. The question will explicitly say. So at the very least, you're looking at AMC lah. So let's take a look. Your concentration of chemicals, you're looking at an average of 0.1 to 1 mole per dm cube. So this is something that perhaps you may not be aware. So actually in the school lab, the chemicals that you deal with, right, the concentration are actually between 0.1 to 1. So why do you need to know this? Because during your planning, the steps where you tell me how much to add, you cannot choose concentrations that won't work. You can't go like a 0.0001 mole per dm cube. Sure, you may actually get to dilute to that extent, but it probably not very feasible. Or you cannot use concentration like 5. 5 mole per dm cube, the concentration is very high. It's likely to be very corrosive, dangerous, and all those. So your experiments should also be sound and theoretically sound and safe. You don't tell me, add 10 grams of sodium into acid. Wow, boom, cannot lah. Safety is of course another concern. So let's start off with you have two practical, that is planning questions inside that you have it with you. So I'll go through the two of them. Then after that, I will also share with you 3 planning questions that you may practice on your own. And the answer key I will upload eventually as well. Okay, so let's look at practical 7B. Remember AMCA, AMCA. So this is actually N18, means this is November 2018 O-level planning question. So let's take a look. So it says that, oh, you have seashell. Seashell has carbonate. Cool. Cockles, which is seashell, said to have contained nearly 60% biomass. Cool. This is an important point here. You're given 1 gram of the shell. You're supposed to have some method to determine the percentage biomass. Oh, and the question also say that, oh, you must note assumptions. Sure. Okay. So let's start off the aim. So actually, planning, I guess, you have a bit more flexibility because we can accept more than one method. What do I mean? So in this case, you're talking about carbonate, right? So essentially, carbonate, you think about it lah. What do we learn involving carbonate? Oh, you will likely think of the acid carbonate reaction, which gives you salt plus CO2 plus H2O. Yeah, okay. So if in this case, what can you actually measure to help you come up with a number which you can calculate? So you see there is a gas involved. Means you can always look at the most obvious one, which is, oh, the volume of gas collected lor. Yeah, there's nothing wrong with that. Another thing you can think of is, if there's gas involved, it means that the mass of the reacting mixture would decrease. So that the decrease can also help you actually. So there's a there's also the flexibility. So it depends on whatever method you choose. So let's say we talk about volume of gas. Okay, let's talk about volume of gas. Sure. So if it's volume of gas, means it's a carbonate, okay, and you need to decide what acid do you want to use. Technically, you can use any acid lah, but I would rather use nitric acid because all nitrates are soluble, safer. I don't want to form some unwanted PPT that complicate things. So in my mind, I'll be thinking, oh, I'm gonna add nitric acid plus carbonate. Okay, cool. This should give you a salt, which is a nitrate salt plus CO2 plus H2O, which you can balance and realize you need to balance it in this manner. Yeah, it's balanced. So this is one way. You can alternatively write it in, oh yeah, this is a cockle salt. Yeah, I think yes. So what can you do next? You need to think, which one, how much do I need to add? Alamak, how? So you think about it. They are giving you 1 gram, isn't it? 1 gram, and the question says 60% of it is carbonate. So 60% of carbonate, 1 gram is essentially 0.6 gram. Then you go like, 0.6 gram. Okay. So you need to do some backward calculation. So if this is 0.6 gram, then what is the mole or equivalent of this? So the equivalent is, again, you don't know what is the carbonate, like whether it's a calcium carbonate or is it whatever. So what happens here is this, you need to roughly calculate lah. So let's say it's 0.6 gram of carbonate, which is this, divide by your 12 plus 3 bracket 16, which is equivalent to 0.6 over 3 times 16, 48, 60. 0.6 divided by 60, which is, okay, let me find a calculator. 0.6 divided by 60. Oh, 0.01 mole. Okay, so we are looking at a number of 0.01 mole. So then you need to start to think, should my acid be excess or should my cockles be excess? So you think, if your cockles excess, that means you will end up with your cockles and the salt. There is no acid. Huh? What's happening? So if that's the case, right, can this be done? Think about it. So what do you do next? Think about it. If cockles is excess, and in this case we are talking about collecting gas, let's try. So if this is, just now we calculated, if this is 0.01 mole, that means your acid should be double the mole, 0.02 mole. And in this case, you want your cockles to be excess. So you will probably be using acid of about lesser lah. So maybe 0.01 at most, because you want this to be your limiting. Which means step 1, you will, okay, let me find more space. I don't have enough space. Step 1, you can say, measure how much volume and how much concentration. So let's say we're dealing with 0.1 mole per dm cube of HNO3. How much volume you need to achieve 0.01 gram? That is 100 cm cube. So measure this one using what? Using agaration? No, you have to tell me what apparatus to use specifically, and even tell me what's the volume. Meaning, you should be using 100 cm cube measuring cylinder. Sure, you can use things like what? More precise things like what? Pipette lah, burette lah, but you must remember that all those things, the maximum volume is does tally. A burette typically takes up to 50 cm cube. A pipette usually takes up to 25 cm cube. So the numbers, you need to use it multiple times, which is preferably not lah. So use a measuring cylinder, okay, and transfer it into a 250 cm cube conical flask. So you might be wondering, wow, why am I doing this? Because the setup should look something like this. You need the conical flask, the gas, because you're collecting the gas, isn't it? Then this is the reaction with your nitric acid, and inside would be your cockles. You do this because why? You have a string here lah, so that you decide when exactly the reaction start. Because you imagine if it's real life, you do this experiment. You put your cockles inside, the reaction start already. Wow, you still have fumbling, trying to attach the delivery tube in here and there. So with a string and this thing inside, you get to decide when to start. So it reduces any uncertainty. So this is your gas range. 100 cm cube gas range, for example. Yeah. So it's good that you can draw. You actually, your setup when you draw it out, right, it will help you a lot. Because the marker will see, oh, you know exactly what you're doing. Your setup looks very legit. Alright. So yeah, you transfer it into this, which is the 250 cm cube conical flask. Okay, that looks good. Then you see, you will find it very difficult to actually put into words. Oh, you need to get a gas syringe, attach it to some rubber tubing, then attach it to the conical flask and everything. So actually, to help make your life easier, you draw the setup. Then after that you can say, oh, you measure. Then after that you can arrange the setup according to your diagram. That a picture speaks 1,000 words. You are essentially doing that. So it's actually just a very smart way. So yes, you measure this and you put it in a conical flask. Yes. Second one, you'll be measure 1 gram of cockles. I know question says they give you 1 gram, but it's always better to measure exactly 1 gram rather than people tell you 1 gram you believe lah. So measure 1 gram of cockle shell using what? Agar-agar-agar-ration. Of course not. Using using an electronic balance. We don't really use weighing scale anymore. Weighing scale sounds like, you know, that ancient system where you can hang the plate and everything, like those Chinese shop, herbal shop, that kind of thing. Then you can measure. It's not really that's the case now. It's more of an electronic scale. Yeah. So you have this. Then after that you can number 3, save your effort, set up the experiment according to the diagram. So in this case, what diagram? So perhaps at this point, this is where you could put your diagram over. See, so smart. So basically with this, right, you are done already. What? Why? So what's happening next? So this is number 3. Okay, once it's set up, number 4. Tug the string and allow the cockles to come into contact okay, allow the cockles to come into contact with the acid and you will start the stopwatch. At the same time. Then you might be wondering, what's happening? Do I stop when all the gas is collected? Or what's happening? So this is where you need to think again. Because yes, you are trying to collect gas. But collecting gas, there's also a few ways to go around it. Why? One way is, one method is what? One method is you collect maybe 10 cm cube of gas. So the time taken to collect, basically time taken to collect a fixed volume of gas. Okay, that is one way. You can also say that, oh, the time taken to collect all the gas. Okay, that's fine as well. Or it could even be, oh no, it could even be the volume of gas collected in maybe 20 seconds, a fixed period of time, a fixed duration of time. So there's a lot of flexibility in this case. So you need to decide what is useful, what is relevant. So in this case, what's happening? You are using excess goggles. So how does that work? If it's excess goggles, then how? So this is where we need to think. So actually you think about it, actually can excess goggles actually work? Because you think if it's excess goggles, that means this 1 gram, not all of 1 gram react. Then the thing is, do you honestly know how much of the 1 gram react? We cannot tell. All you have is the volume of gas, but you don't know how much of the goggles react to give you the gas. So that means at this point, oh no, I can't do excess goggles, which is fine. Because why? Okay, this is me to mimic you doing the question in real life. Is it possible that when you do halfway, then you realize, hey, wrong method? So be it, no? We just adjust accordingly. No? So now we go back and adjust. So that means no. So we should actually let the acid be excess, because when the acid is excess, the solid goggles will react fully. Okay. So now we're trying to tweak things around. We want this to be limiting. If this is limiting, that means I want this to be excess. So that means that I should be probably not doing this. I should be probably aiming at a 0.1 mole. That's pretty high. So that means that this segment I should change it to. I have to change it to perhaps, because it's a higher concentration, 1.0 mole per dm cube of 100 cm cube, which still gives you this. Measure 1 gram, yes. Tug the string. Yeah. So now coming back. Do I do this? Do I do this? Do I do this? So think. If you say the time taken to collect 10 cm cube of gas, don't seem very relevant one. I thought you are trying to find out all the carbonate inside, which means you should find out the time taken to collect all the CO2. So for this example, this is not applicable. Perhaps other experiment, when you are when you're comparing speed, that will be a good choice. Time taken to collect all the gas, yes. Volume of gas collected in 20 cm cube, again, this is not relevant. Perhaps is to use to compare things like how does this factor affect your reaction. So we are at number 5. So number 6, you will stop the stopwatch and when no more gas is evolved. And record the... Actually, in this case, in this particular example, you don't want a stopwatch. It's also perfectly fine. Because eventually, the only thing you want is actually the recording of the volume. So we reach this step, you go, actually, I don't need my stopwatch. So therefore, this can be an optional step. So this is to mimic your reality. When you do this planning question, definitely you do halfway through, you think, something is not right. Then you can go back and edit. It happens. So don't need to feel stress or feel that you need to go for perfection. It happens. So actually, you don't really need this part. Don't need lah. You just say, record the volume, or rather the total volume of gas collected. Okay. So actually with this, you are done with your collection already. You already told me the method, step 1 to step 6. You told me the aim. Did you tell me the aim? We didn't really explicitly say the aim. So actually for the approach segment, so this is where you can backtrack again. Approach segment. So it is a very simplistic statement. You just say, react excess nitric acid with 1 gram of cockles and record, or rather collect gas evolve using gas strange. Yeah, that's essentially what you're doing. So the approach is very nutshell. Anybody who read your approach, they will know like, you're doing this. Okay, sounds good. The lengthy part is the method the steps. So AMC, C for calculation. Then what happens now? So you can just say, calculation. So you can say, let the volume of gas collected be x cm cube. Okay, that sounds good. So x cm cube. Then after that, what do you need to do? You are trying to essentially find what? The percentage by mass of carbonate. So we have an equation here, right? So let's continue with this equation to help us. So I'm gonna copy over just to make our life a bit easier. So easier to refer. So this equation here. So what you have is x cm cube, and x cm cube is this. How do you find something regarding this? Mole concept. So you can go, mole of CO2 is x over 1000, which is x dm cube divided by 24, equal to x over 24000 mol. Okay, that's cool. 1 CO2 is to 1 CO32 minus, which you can see from the ratio. So that means, I have the mole of my carbonate already. X over 24000 mole. That's pretty decent. What exactly do they want? Think. They want you to find percentage by mass. Which is mass. Okay, sure, then let's find mass. So the mass of carbonate would now be x over 24000 times 12 plus 3 bracket 16 equal to 60x over 24000, which your calculator will help you simplify into x over 24000 400 gram. Yeah. Then after that, so again, come back to the question. It says you're supposed to outline a method to determine the percentage by mass of carbonate. You don't need to prove whether it is 60% or not. But the 60% is to help you have a rough number so that you can do your calculation. You have the mass. How do you find your percentage by mass then? Of carbonate in cockles. X over 400 divided by the 1 gram times 100%. 100 x over 400, which means you get x over 4 Okay, that's your final answer. That is what we are trying to get. That's it. Then in this question, they did ask you to give me assumptions. Sure. Assumptions. What assumptions do you think I can say? Oh, I mean, we have always been. So yeah, it's what the cocoa 60% is your carbonate. Oh, okay. So we'll say that the other components or other chemicals in the cockles, we assume that they do not react with the acid. Because if they react and somehow they produce gas, then your volume of gas would be different and do not form gases. Yeah, so this is an example. Assumptions cannot be things like, assume that the student do properly and collect all the gas. That is just basic things that people require lah. I mean, you do experiment, of course you do it properly. That is a norm rather than it's an assumption and everything. Yeah, so that's about it. This will give you about 4 or 5 marks. So you might be wondering, what about the mass of reacting mixture? So it's a similar experiment if you are referring to mass of reacting mixture. It's still the same foundation of acid carbonate. But in this case, you'll be measuring you probably look something like this lah. Your mass balance. Then you will have your conical flask with your solids, for example. So if that's the case, you'll probably be measuring the mass, or rather total mass start. Then total mass at the end when the mass reading no longer changes, which means all the gas give out. Then with that, the difference is actually just the mass of CO2. Then on the same thing change to mole, then ratio, so on and so forth. That can be done as well. So when gas is involved, you can choose the very common way of measuring the gas involved, or you can also look at the mass of the reacting mixture. Calculate the volume of gas involved or mass of reacting mixture. So that's about it for this question. Yes, it's a little bit overwhelming, alright? So take a while, think about it. Okay, next practical, which is practical number 5. We have done it, but the planning segment is empty. So let's take a look at planning segment again. AMCA. Okay, let's take a look. In this question, they don't need A because the question didn't mention any assumption. So fine, don't need A. But you still need AMC. In this case, did they write the mark weightage? No, didn't write the mark weightage. So what happens? It says a label of a product give you the concentration in gram per dm cube. Cool. And apparently you need MR. Cool. So this whole experiment is to find your MR. Cool. And they're very nice because why? They already tell you must use a certain method or a certain reaction, which means easier for you. Because you don't need to worry, what method do I use? They tell you do this method. You follow, you come up with your steps, and that's about it. So it's a good thing. Yay. And by the way, this is actually N20, meaning this is 2 years ago O-level question. Okay, other keywords I have seen here is this solid acid. Okay, so we are doing a solid sample. And they even tell you everything. It even tell you, measure the volume involved. There is another key phrase here that students would missed out, which is your seniors lah. Here, your method is gas collection through the displacement of water. So you're so used to using a gas stream, you just forgot about this method. Even if there's right down there for you, you still gas stream. Then it's not really a question lah. Then you lose mark lor. So same thing. So they say gas collection. Okay, that means you are going to collect the gas. You can't really use other things such as weigh the mass of the reacting mixture. No? So in this case, and they even want a diagram, so you would try and draw. My drawing is private limited lah, huh? So I will try. So even if private limited like of me I can try, means you can do it too. So same thing, I would want to control the experiment and don't start it until I say so. The string and all. Oops. Then you probably have a inverted measuring cylinder here. You remember doing this thing before? We did, right? As a group work. Yeah. So this is your measuring cylinder. Yeah, so this is a water trial. You just to fill with water. Then this is your beehive nest and everything. You recall all these things? Then this is a measuring cylinder. I guess 100 cm3 measuring cylinder. Yeah, I think my drawing is pretty nice. Yes. So same thing. You're gonna the approach is already there. You don't even need to tell them the approach. Like they give you everything, which is fine. I'm not complaining. Then question. So they even tell you are supposed to tell me the parameters. Okay, that isn't hard. What are you gonna measure? That is also not hard. And explain blah blah blah. So this is calculation, isn't it? So bring it on, man. Bring it on. Okay, so what's gonna happen is this. So let's think. You are supposed to determine the MR lah, basically. So how should your acid be excess or should your carbonate be excess? Would it make a very big difference? Think. So they didn't tell you what exactly here, but you can decide lah, because some solid acid. So I think you think about it lah. So it's basically an acid in the solid form plus carbonate, right? Sure. So if you are thinking of excess acid, the problem now is that means you have no clue how much acid is used up. Okay. So even if you know, like let's say 30 cm3 of gas of CO2, you don't know this is produced by how much acid. That means you can't continue. That means this is the wrong method. So we should be aiming for excess carb Na2CO3. And they didn't really give us any number, right? Then you decide, lor. Okay, what am I talking about, right? Okay, so I'm gonna write the equation so that it's easier to refer for us later. CO2 plus H2 plus 2NaA. Okay, so as you see, something is very, 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 very wrong here. It's H2O lah, obviously. How can it form two gases here? If you didn't realize that, let's be more careful, yeah. Okay, so we have the equation here. Okay, let's make it bigger. And we are trying to make sure that this is excess. Okay, that is sure. If that's the case. So we are supposed to use solid acid. Oh, so what's happening here? So you need to decide how much solid to use. Then you'll probably be like, huh? Can I use 1 kg? Or can I use 0.005 gram? How do I know? So in terms of mass, right, typically mass of solid that we use is, we don't use things that are overwhelming. 1 kg is a lot 0.005 is very little. So we'll probably aim for things within like 0.5 gram to maybe 5 gram. 10 gram I think also can lah, but maybe not more than that. Yeah. So this one, let's say the standard concentration of 1 mole per dm cube, and let's say we use 100 cm cube. Let me see this setup. Okay, let's say we use 100 cm cube. That means we are dealing with a 0.1 mole. So if this is 0.1 mole, my acid by right is 0.2 mole. Okay, looks okay. But you want your Na2CO3 to be as excess. So that means I should be looking at what? 0.1 mole, safer. So if this is 0.1 mole of HA, then what is the mass here that we're supposed to deal with? We actually don't know. That's why we're supposed to find an MR. Then so be it lah. But the problem is, if you really don't know, then how much mass are you gonna use? This is quite unsettling, isn't it? Did they tell you anything else? They didn't. Oh no, this is stressful. So let's screw up and see. Did they tell you anything? Like literally anything? Actually, they really didn't tell you anything, which is fine. So in such a situation, you will probably panic. So again, I'm gonna calculate and plan for the worst case scenario. Huh? What are you talking about? So basically, I'm gonna tell you this. So that even if I talk about a very huge MR, let's say a huge MR of 200, which is probably, we don't really deal with 200, right? But let's say somehow by some freak accident, it's 200. Okay, no, don't even need 200. Okay, 100 is also pretty safe. 100. So if we are hypothetically speaking, 100 MR, that means it will only be 10 gram of HA. Oh, so like that I get 10 gram. That means 10 gram would be pretty safe. So in such a hypothetical situation, then 10 gram, oh okay, I think you can use 10 gram in this case. Oh? Yeah, if not, how else? So now I roughly know the number, then I'm gonna calculate. So step 1, oh no. Step 1, we can measure 10 gram of solid sulfamic acid. Using what? Using an electronic balance using an electronic mass balance. Okay, electronic mass balance. Yeah. Then second step, we will measure 100 cm cube of 1 mole per dm cube. sodium carbonate solution using what we call a 100 cm cube measuring cylinder. Okay, then what's next? And transfer into a 250 cm cube conical flask. Then, oh no, how am I going to describe the setup? I'll just say, oh, setup. The experiment has shown in the diagram. I think that's a very ingenious way, right? You're not trying to explain out step by step. It's a little bit tough, but this kind of measuring stuff, you have to say that because you don't show your measuring step in your diagram. Then after that, the reaction start lor. So in this case, what happened? So the same thing has previously, remember just now earlier on, this case? Okay, where is it? How gas evolve Am I gonna figure out how long it takes for all the gas, you know? So that's where you need to think about it again. This. So it's not about time taken to collect a 10 cm cube of gas because again, remember our context is the HA is limiting, which means the HA will react fully. You want it to react fully. Why would you bother finding the time taken to collect a little bit of gas? You want it to give out all the gas. Yeah. Yep. Then number 4. What would you so you don't need a stopwatch, you don't really care about time. So actually you just want to collect the gas. So you just say, oh, record down the volume of gas evolved. And let it be x cm cube. Okay. So then last step, show your calculations. So mole of CO2, mole of CO2 is x over 1000 divided by 24, give you x over 24000 mole. Ratio wise, what does the ratio tell me? Oh, 1 CO2 is to 2 Ha. 1 CO2 is to 2 Ha. So it's Ha. So mole of Ha is times 2. So it's 2x over 24000 equal to x over 12000 mole. Okay, that's pretty decent. Then what do you do next? What do you want? You're trying to find MR, isn't it? Yeah, so you see, you have the mole of Ha. You have the mass of Ha. Huh? What am I talking about? It is 10 grams. What? We measured it at the start. You have mole, you have mass. Oh, I can find my MR already. MR equal to so you might be remembering it has mole equal to mass over MR. That is correct. Then you manipulate it. So MR will be equivalent to mass over mole, which is 10 divided by x over 12000, which is equivalent to 12000 over x. Yeah, and that's it. That's your answer. You found your MR. Oh yay. And that's about it. So again, take time to digest. Understand it has been quite a bit. I will be uploading 3 extra planning questions for you to attempt. You should attempt them one at a time. After the first one, you check your answer. Don't attempt 3 at one go. Later you have the same mistake for all 3. Yep. So that's all for planning. Thank you for listening. Goodbye.